This is every algebra question on the SAT, part 2, going into linear equations with one variable. In this case, we're going to be doing the medium questions. So we'll dive right in, but questions will all have a question ID, and all of the question IDs and the timestamps, which is the exact minute and second where they occur in this video, will be in the description below. If you did any of these problems on your own and want to go to a specific problem, just look in the description, look for that ID, and then you can click on the timestamp that's there. All of these questions, as I said in the intro there, will be linear equations with one variable. And these are the medium difficulty ones, which means that they have 2 out of 3 for their difficulty. This first question, they give us this equation, 3 times the quantity 2x minus 6 minus 11 is equal to 4 times the quantity x minus 3 plus 6. If x is the solution to the equation above, what is the value of x minus 3? So they're doing the same thing that they did in a lot of the easy questions where, the equation's not that hard to solve and this step doesn't really add that much, but they are trying to trip you up. And in this case, they're hoping that someone's going to solve for x instead of x minus 3. Make sure you solve for what they're looking for. So whatever you get for x, make sure you get x minus 3, or you can see there's an x minus 3 here. This can be turned into x minus 3. So you can solve it without actually solving for x. I'll show both ways. So I'll start by doing the way that you don't solve for x, and then I can show you how you do it with x. Either way will work. So in this case, we've got 3 times 2x minus 6. You can remove the 2 out of this. So it's basically the opposite of the distributive property. We're factoring a 2 out. So this divided by 2, this divided by 2, and then the 2 goes out front. So 2 times 3 gives us 6. So this will be 6 times x minus 3 minus 11 equals 4 times x minus 3 plus 6. Now I've got this. And now instead of using x minus 3, let's substitute in something else. So let's say, I don't know, p can be x minus 3. You can use y, you can use anything. You could also just leave it as x minus 3. But so in this case, instead of 6 times x minus 3, I'm going to write 6p minus 11 equals 4p, because it's 4 times x minus 3. Again, that p is in place of the x minus 3, plus 6. All right, so now we're just solving for p, because p is x minus 3. That's what we're looking for. So I'm going to subtract 4p from both sides, get all of my p's on one side. 6p minus 4p is 2p. So we got 2p over here. And then to get the p's alone, we're going to get rid of this minus 11, so I'll add 11 to both sides. So this 4p cancels out, negative 11 plus 11 cancels out, and then we get 6 plus 11, which is going to be 17. So 2p is equal to 17, which means that if I want to get p, to get rid of that multiply by 2, you divide by 2 on both sides, and p will be 17 halves, right? Which you could write that as 8.5. They're looking for a fraction. So p is 17 halves, and again, p is x minus 3, so x minus 3 is equal to 17 halves, and that would be your answer. Now again, I just put in that p to make it easier to keep track of, easier to do the math. I basically subtracted 4 x minus 3s from the 6 x minus 3s over here, which left us with 2 x minus 3s. So you can think of it that way if you want to leave it in terms of the x minus 3. All right, so that's how you could solve it without finding x. We never actually found what x is. Obviously from here, you could just add 3 to both sides. But if you feel more comfortable just doing it how you would in a normal algebra class, we can just distribute this 3. So 3, or I'll rewrite the whole problem. 3 times 2x minus 6 minus 11 equals 4 times the quantity x minus 3 plus 6. All right, you can just distribute your 3, and then here we distribute the 4. So 3 times 2x gives us 6x. 3 times negative 6 is minus 18. So negative 18 minus 11. And then 4 times x is 4x. 4 times negative 3 is minus 12. We still have plus 6. So in this case, we have 6x minus 18 minus 11. So negative 18 minus 11, you're making it more negative. It's going to go to negative 29. And then here we have 4x minus 12 plus 6, you're getting it closer to 0, so it's actually going to be negative 6. And now you could subtract 4x from both sides. Just leaves us 2x over here. And then we could add 29 to both sides to get rid of this minus 29 over here. Right, this cancels, this cancels. We get 2x equals negative 6 plus 29 would be 23. Right, it's basically like 29 minus 6, which means that x is equal to 23 halves. And then we want to find x minus 3. So x minus 3 equals 23 over 2 minus 3. And then you could just, to make that into halves, you would multiply 3 by 2 over 2. Another form of 1. So if you multiply it by 2 over 2, it doesn't change the value, but it will just have the same denominator. So we have 23 over 2 minus 6 over 2. 23 minus 6 is 17, so it's going to be 17 halves. Right? So you get the same answer. Again, I think this way was probably faster. That's why I did it that way. I looked at what I was solving for. A lot of times if they have you solve for something that's not x, there might be a shortcut, right? There might be another way to solve for it. But doing it this way, you can see it didn't take that long. If you have a calculator, you wouldn't even have to worry about this 3 times 2 over 2. You can just type in 23 over 2 minus 3 and then just give your answer in fraction form. Or even if you don't know how to get your calculator to give you a fraction back, still, it could be worth looking into, but you could just type all of these fractions into your calculator and see which one is the same decimal as your answer. So that's another method. But either way, 17 halves will be your answer. All right, next question. We have 2n plus 6 equals 14. A tree had a height of 6 feet when it was planted. All right, so that's the initial, right? It's like the y-intercept if it was a linear function. The equation above can be used to find how many years n, so n is the number of years, it took the tree to reach a height of 14 feet. So 14 is like the end height. Okay, n is the number of years. You're going to multiplying that by 2. So that means every year it's going up by 2. Right? It's like the slope. Which of the following is the best interpretation of the number 2 in this context? Again, we just said it's the slope, right? You're multiplying it by the number of years. And what is it? The height in feet. So that's how many feet it grows per year. So the number of years it took, nope, the number of years is n. The average number of feet the tree grew per year. Okay, that sounds good. The height in feet of the tree when the tree was 1 year old, no, that would just be when n equals 1, what's the output, right? That's a different thing. The average number of years it takes similar trees, no, what are they talking about? It's just B. All right, now you can see I knew it would be from when I read it the first time, but I still went through just to make sure, right, there wasn't something else that jumped out. You should be able to eliminate, even if you know what the right answer is, it's still good to eliminate the other options sometimes. In this case, we have 2x plus 16 equals a times the quantity x plus 8. In the given equation, a is a constant. If the equation has infinitely many solutions, what is the value of a? All right, so infinitely many solutions for a one variable equation. I know there is a second variable, the a, but we're plugging something in. So ultimately, it will just be x's on here. Infinitely many solutions just means you have the same thing on both sides. Right, so like 8 equals 8, right? That's always going to be true. Or if they had like x plus 3 equals x plus 3, for any value of x, it's going to be the same when you add 3 to it. All right, so that's when there would be infinitely many solutions. The only time that you'd have like no solutions would be if it was x plus 3 equals x plus 4. Right, whatever x is, they will never be the same because this one will always be 1 higher, right? The right side would be 1 higher in that case. Most equations would just have, or most linear equations would just have one solution, one variable linear equations, I guess I should say. But yeah, for this one, we want to find a way that the coefficients on the x will be the same. And, you know, if it's going to be infinitely many solutions, then also the constant you're adding to it should be the same. So in this case, we have 2x over here. So when we distribute this a, we'll end up with ax plus 8a, and we want that to be equal to 2x plus 16. All right, so a is the coefficient in front of x. That should be the same as 2, and 8a should be equal to 16. All right, so a should be 2, and 8a should be 16. Well, a equals 2. That's true when a is 2. And then if you plug in 2 here, that'd be 8 times 2 equals 16. So 16 equals 16, again, when a is 2. All right, so you need a to be 2. So these ones really are not that tough. They're just, you have to make sure that you know what it's talking about when they mean infinitely many solutions for a one variable equation. And I know, again, a is a variable, or a looks like it's a variable, but it's actually what constant do you put in there? Because once you say a is 2, it stays as 2. It's not changing. And then it's just saying for any value of x, like if x is 0, if x is 5, if x is 35, if x is negative 2, if x is 1,000,000, no matter what, if it's 2x plus 16 on this side and 2x plus 16 on this side, then it doesn't matter what x is, they're always the same. All right, here we have the quantity b minus 2 times x equals 8. In the given equation, b is a constant. If the equation has no solution, what is the value of b? So if it has no solution, then you're going to have two different things on the two different sides. All right, well, just looking at it, it looks like you're going to have to, because there's no x on this side, it looks like this b minus 2 is going to have to be equal to 0, because then you'd have 0 times x is 0, and 0 is never equal to 8. Yeah, I mean, I can just distribute it to prove that point, but basically, if you distribute the x to both of these, you'd get bx minus 2x equals 8. Now, bx. Yeah, I mean, as long as this does not, like, the x's don't cancel out, then if you have x on one side and a constant on the other side, there will be one value that makes that true. And if you had it so, yeah, there's no way to make it infinitely many for this one, I don't think, because you can't get 8 equals 8. Bx plus 2x. I guess you could also think of it this way, is like if you want to have the same coefficient on your x term, you could add 2x to both sides. You'd get bx equals 2x plus 8, and then b has to be the same as it is over here, so b has to be 2, because 2x equals 2x plus 8, right? That's never going to be true. This right side would always be 8 higher. But again, the other way you could think of it is just 0 is never equal to 8, right? So that will never be true. So if b minus 2 equals 0, then that would mean that b minus 2 times x would be 0, right? Because that's 0 times x equals 0. So you could just figure out when is b minus 2 equal to 0, and then just add 2 to both sides. That would mean b is equal to 2, right? So either way, you're getting that b is 2. If this one did confuse you, so say you got this one on the question or on the test, and you weren't feeling comfortable with the ones where it has no solution or infinitely many solutions or whatever, just look at the options and plug them all in and see which one would actually make it true, right? So you could say, all right, if I plug in a 2 here, right, that's option A, 2 minus 2 is 0, 0 times x, well, it doesn't matter what x is, that's going to be 0, anything times 0 is 0. So 0 equals 8, that's never true, right? So you could figure out that's true. If you plugged in the 4, you get 4 minus 2 is 2, 2x equals 8. Well, that's true when x is 4, right? 2 times 4 is 8. If you had 6 minus 2, that'd be 4. 4 times x equals 8. Well, that's true when x is 2. And then b minus 2 if x is 10, or sorry, b minus 2 if b is 10 would be 10 minus 2 is 8. 8 times x equals 8. That's true when x is 1. So it couldn't be any of these. They all have one solution. A is the only one that has no solutions. So the multiple choice can help you out there. It's probably good to be comfortable that you could do it even without the multiple choice in case this concept came up in a short answer question. But just always rely on your multiple choice if you have it, even if it's just to check your answer afterward. Here we have a times the quantity 3 minus x minus b equals negative 1 minus 2x. In the equation above, a and b are constants. If the equation has infinitely many solutions, what are the values of a and b? All right, they really love these infinitely many solutions and no solutions for these one variable equations. So again, you could say, oh, well, it looks like there's 3 variables. A and b are constants, right? So they're not variables. Once you put a value in for them, they're not changing. So we want there to be infinitely many solutions, so it should be the same on the left and the right. You probably would want to distribute the a. So you'd get a times 3 is 3a. A times negative x is minus ax minus b equals negative 1 minus 2x. So we have our constants, I'm going to underline in red. Over here, your constant is just negative 1. And our x term, the term that just has an x, something multiplied by x, I'm going to do a squiggle in purple under it. So we have on the left side, 3a minus b. On the right side, negative 1. And we want it to be infinitely many solutions, which means the same on the left and the right side. So 3a minus b equals negative 1. So we have to choose a value of a and b that would make that, that difference there be negative 1. And then we also want negative ax, so the x term, to be equal on the left and the right side. So negative ax equals negative 2x. Well, this is a little easier because negative a would have to be equal to negative 2, which means that a is equal to 2. Right, so a has to be 2, so we can cross out c and d. Right, negative a equals negative 2x. Or sorry, negative a equals negative 2, that means a equals 2. And now using this 2, we can plug that into the 3a minus b equals -1, and we get that 3 times 2, because that's our value for a, minus b should equal -1. 3 times 2 is 6. 6 minus b equals -1. And then to get b alone, you could just subtract 6 from both sides, which gives us that -b is equal to -1 minus 6 is -7, so b would be 7. All right, so a should be 2, b should be 7. That's option B. Now, what I really would recommend with, especially with questions like this, where there's a lot of negative signs involved, and it's not really the kind of math that you're necessarily doing in a math class. Like usually in algebra classes, they probably wouldn't ask you what constant values would make this be an equation with infinitely many solutions. Usually they give you the equation, they say how many solutions are there, infinitely many, none, or just 1. But in this case, once you have your answer, plug it in and see if it actually is true. So plug in 2 for a, so 2 times 3 minus x, and then plug in 7 for b, minus 7, is equal to -1 minus 2x. And let's see, distribute the 2. 2 times 3 is 6. 2 times -x would be minus 2x. Minus 7 equals -1 minus 2x. Now we have 6 minus 7, our like term. 6 minus 7 is -1. So -1 minus 2x equals -1 minus 2x. Right, we have the same thing on the left and the right. So it's always going to be true. You could even add 2x to both sides, which just cancels it out over here. And over here, we get -1 equals -1. No matter what x is, -1 will always be equal to itself. So it would always be true. Infinitely many solutions. All right, so that's another way that you could do it. If you didn't feel comfortable doing the stuff that I did at the beginning, you could just plug in all of the options. Right, plug in a is 2, b is 1, a is 2, b is 7, a is -2, b is 5, and so on. And then you'll find that b would be the only one that should work. Here we have a word problem. An agricultural scientist studying the growth of corn plants recorded the height of a corn plant at the beginning of a study and the height of the plant each day for the next 12 days. The scientist found that the height of the plant increased by an average of 1.20 centimeters per day for 12 days. All right, so 1.20 is like the slope, and then you multiply that by the number of days. If the height of the plant on the last day of the study was 36.8, what is the height in centimeters of the corn plant at the beginning of the study? So it's not on day 12. It's not like it was day 1 and then day 12. It's 12 days after it started. So you could say it's day 0 and day 12 or day 1 and day 13. It doesn't really matter. But it's going up 1.20 each day for 12 days. So this is the amount it grew, 1.2 times 12. Here, let me put that in parentheses so it's not confusing. And we're adding that to the initial height. Right? We don't know what the height was at the beginning. I'll call it B for beginning. But that would be equal to the final height. Right? You had your beginning height. You add how much you grow, which is the average growth times the number of days it was growing, that average amount. And then you would end up, that sum would end up being your final height. All right, so now we can just multiply 1.2 times 12, which this is like 12 times 12 is 144. So in this case, it's going to be 14.4. Sorry, it shouldn't be equals. It should be B plus 14.4 equals 36.8. And now to get the beginning height alone, we just get rid of this plus 14.4 by subtracting 14.4 on both sides. Cancels it out over here. And that leaves us with B is equal to 36.8 minus 14.4, which should be 22.4. 22.4 centimeters is your height. And now to check that, just plug it back in. 22.4 plus 1.20 times 12. 1.20 times 12, again, gives us 14.4. 14.4 plus 22.4 would be 36.8, which is what we want it to be. Okay, so that checks out. Here we have 1/3 times the quantity x plus 6 minus 1/2 times the quantity x plus 6 equals -8. What value of x is the solution to the given equation? Oh, it was 1/3 and 1/2. For a second, I just looked at it again and thought they were both 1/2. I'm just thinking that's going to get rid of it. So there are a couple ways you could do this one. You could distribute the 1/3. So you could do 1/3 times x, 1/3 times plus 6. And you could distribute the negative 1/2. Make sure you distribute that negative as well, like that. And that would give you x thirds plus 6/3 is 2. Right, 6 divided by 3. And then we'd get minus x halves minus 3. Now just be careful, make sure you distribute the negative sign, and that would all be equal to -8. So then you could combine your like terms. So we have these are like terms, and the x terms are like terms. So we get x over 3 minus x over 2 plus 2 minus 3, that would give you -1, is equal to -8. And then to get our x's alone, we'd add 1 to both sides. Now, for these to add them, or in this case to subtract them, you need to have a common denominator. So we're going to get them in terms of sixths. So you can multiply this by 2 over 2, multiply this by 3 over 3. Right? Those are different forms of 1s. They don't change the value, but they give you the same denominator. So we get 2x over 6 minus 3x over 6 equals, and then we said the -1 plus 1 cancel, and -8 plus 1 is -7. So 2x minus 3x would give you -x over 6 equals -7. And then to get x alone, you could multiply by -6. That gets rid of the negative and the 6. Some people will get confused by that, so I'm just going to say multiply by 6, which gives you -x equals -7 times 6 is -42. And then if -x equals -42, that means x is 42. Right? You think of that as dividing by -1, multiplying by -1, or just negative something equals negative something, right? Then the somethings are the same, x and 42. All right, so x is 42. That's one way you could do it, right? If you feel comfortable with distributing a negative sign and with combining fractional coefficients, right? The 1/3 x and the 1/2 x, that would work. One way that I probably would have told my algebra students to do it this way, just because I was afraid they would mix up the fractions, is you can multiply by something to get rid of the fractions. So from the get-go. So in this case, right, if you multiply everything by 3, it will get rid of the 1/3. If you multiply everything by 2, it gets rid of the 1/2. So I'm just going to say multiply every part by 6. And you don't have to multiply the things inside of the parentheses by 6, because you're multiplying the front by 6, and then that 6 gets distributed to everything. Right, so 6 times 1/3 would be 2. 6 over 3 is 2. So we'd end up with 2 times x plus 6 minus 6 times -1/2 would be -3. And half of 6 is 3. So minus 3 times x plus 6 equals, and then 6 times -8. Don't forget to do it on the right side as well. Equals -48. All right, so once you have it like this, then you don't have to worry about the fractions. I'm pretty comfortable with fractions myself, and I know I was when I was taking the exam, but some people feel like that's a good opportunity for someone to make a mistake. So especially for a short answer question, this could be a good way to check it out. So you just distribute that 2. That gives you 2x plus 12. 2 times x is 2x. 2 times 6 is 12. Minus, and then -3. Again, you still have to distribute the negative to both. So -3 times x is -3x. -3 times 6 is -18. I think a lot of people will probably forget to distribute the negative to the 6. So just be careful with that. And that would be equal to -48. So we'd get 2x minus 3x is just going to be -x. 12 minus 18 is -6. Right, so we'd get -x minus 6 equals -48. To get the -x alone, we'd add 6 to both sides. Gives us -x equals, well, if you add something to a negative number, you're making it closer to 0. So it's actually going to go down in absolute value. It's going to go to -42, which means, again, that x is 42. All right, so you can see that wasn't much faster than doing the fraction way. Probably saved a little bit of time, but it just eliminates the needing to find a common denominator and the opportunity for someone to mess up the fraction math. Right, so you can do it like that. The last way that you could do it, I mean, there's probably a couple other ways you could do it, especially if you're using a calculator, but especially after you've distributed it, so say, or after you've multiplied it by 6. So if you did that first step that I said, and you had 2 times x plus 6 minus 3 times x plus 6 equals -48, like that. You could combine these, like say you could call x plus 6, maybe call it y, Or let's do a different variable so it doesn't seem like it's a linear function. Say you call it, I was going to say s, but s looks like a 5. So you always choose a variable that doesn't look like a number that's possibly in the equation. Let's say x plus 6 equals m, right? So maybe m for math. Then we get 2 times m minus 3 times m equals negative 48. All right, so again, I just plug that in place of the x plus 6's here. This is the m, this is the m, right? And then 2m minus 3m gives you negative 1m, or you could just call that negative m. And so negative m equals negative 48. And that would mean that m equals 48. Okay, so m equals 48. And then you could just plug this in to the x minus 6 equals m. So what we substituted in. So we just solved for what x minus 6 equals, which is 48. X minus 6 equals 48. You can subtract 6 from both sides. You get that x equals 42. All right, so that way, actually that probably simplified it a little bit. You would have to think to do this, and that's just so you don't have to worry about distributing the 2's. The nice thing about this is then, you couldn't forget to distribute the negative when you distribute that negative 3. I do think, that's an important skill to have. Make sure that you can distribute properly. So remember to distribute that negative, but even if you're a little bit worried about it, you could use this strategy, or you could do this way after you've finished if you have extra time to check it. Because you can see, that didn't take too long, other than maybe explaining what I was doing with it. Here we have a line segment that has a length of 115 centimeters, and it's divided into 3 parts. All right, it doesn't say if they're equal or anything, but one part is 47 centimeters long. The other 2 parts have lengths that are equal to each other. Okay, so we have the entire thing is 115. We have one part is 47. And then we've got 2 parts that are the same length. So we call that x and x. All right, what is the length in centimeters of one of the other 2 parts? So we're just trying to find what x is. All right, so 47 plus x, which would be 2x, right? We have 2 x's, is equal to 115. One of the other 2 parts. Just be careful because they could say what would be the length of the 2 parts combined. In this case, they're asking for just one of those 2 parts. I think that's one of the keys for the SAT, especially for the math section. Just always really focus on that last sentence. What are they looking for exactly? So many people do the math correctly. They do all the hard parts right. And then they just, maybe they ask for x minus 3 and they give them x. Or maybe they ask, right, what's half of x? And then, So just make sure, don't do all of the hard stuff and then not get credit because you didn't read what they're looking for. So they just want one of those, which would just be x. All right, so we're just solving for x here. Minus 47, minus 47. This really could have been in the easy section, I guess, just because you have to set it up yourself. It makes it a little trickier. But that would be 2x is equal to 115 minus 47, which would be, 68? And then to get x alone, you just divide both sides by 2. Right? We have 2 times x divided by 2 is just x. And then 68 divided by 2 would give us 34. All right, so that's 34. Quick check, 47 plus 2 34s. It should be equal to 115. That's what we're checking for. 47 plus 34 would give us 81. 81 plus 34 would give us 115, which is equal to 115. All right, so that checks out. All right, perfect. Here we have 5 times the quantity x plus 4 equals 4 times the quantity x plus 4 plus 29. What is the value of x plus 4? All right, I'm going to do the method I did with the m before, which is just to say x plus 4. So actually what we're solving for, we're going to call that, let's do, in this case, let's do k. All right, so x plus 4 is k. So we have 5k up here. Right, k is just in place of the x plus 4. And then that's going to be equal to 4 times k. Again, that's x plus 4 plus 29. Right, if you want to solve for x plus 4, which is just, we're basically solving for k, we want to get our k's alone on one side. So subtract 4k from both sides. 5k minus 4k gives us 1k. So it's just going to be k is equal to 29. Which again, we said k is x plus 4. That's why I made that. You can make it any variable, right? You can make it y if you want. I'm using stuff other than y, so I'm not making people think it's a linear equation. But x plus 4 is equal to 29, which would be our answer. All right, so I didn't even have to find what x is. Obviously, from here, you could find x pretty easily. Just subtract 4 from both sides. X should be 25. But they're not looking for x. They're looking for x plus 4. And I did this partially. I didn't even have to use the distributive property there. It just made the math a lot easier. Now, if you'd like to solve for x first, or even you could just think of it as, okay, I have 5 x plus 4s over here, and then I'm taking away 4 x plus 4s. That leaves me with 1 x plus 4. So you could think of it that way and not use a k. Right? The k just kind of simplifies that for explaining it. But you could also distribute the 5. You get 5 times x is 5x. 5 times plus 4 would be plus 20. And that would be equal to, you distribute the 4 here. 4 times x is 4x. 4 times 4 is 16. No, it's not equal to, that's plus 29. All right, so you could just do it like this. Minus 4x, minus 20, minus 20. Right, so I'm getting the x's all alone on one side. Right, 4x minus 4x is 0. 5x minus 4x is just 1x, so x. And then I'm subtracting 20 from both sides to get rid of the plus 20. So the x's are alone. So 20 minus 20 is 0. 29 minus 20 is 9. So x equals 16 plus 9, which gives us that x equals 25, like I said before. And then the one thing with if you're going to solve for x, just be really careful because they're not asking for x. And a lot of times the SAT doesn't like to ask for the actual variable. They ask for something weird like x plus 4, which in this case wasn't so weird because the x plus 4s do appear in it. But x plus 4 equals 4 more than 25. So you do 25 plus 4, which equals 29. Right, so you get the same answer. This one, they were mean. They did make 25 an option. So just if you're going to do the way where you solve for x, be really careful. The other thing, especially once you have your answer, it doesn't take that long to check it. Just plug your answer back in for x. Because then if you did 25, you would catch your error. Then if you did 25, you would catch your error really quickly. So we could say 5 times, in this case we said 29 plus 4 is equal to 4 times, again, x is 29 plus 4. All right, so let's see if that works. Plus 29. That's not right, is it? Oh, I'm dumb. All right, here's what I'm messing up. I substitute in as if x is 29. X should be 25. Right, so here, I thought I caught an error, but I actually didn't catch an error. I caught that I had an error in checking it. All right, so x plus 4 is equal to 29. Now, if we look back at the equation here, x plus 4 is the entire thing in there. So if we're going to plug in this value, x plus 4 equals 29, we have to plug that 29 in for the entire x plus 4. Right, so you have an x plus 4 here, and you have an x plus 4 here. So we can do 5 times 29, which would be 145. 5 times 30 is 150, and it's just 5 less than that. Equals 4 times 29. All right, so we do the same thing. 4 times 30 would be 120. It's 4 less than that, so it's going to be 116 plus 29. So 145 equals 116 plus 29. Let's see if that's true. 116 plus 29 would be 145. So 145 equals 145. That checks out. All right, or if you wanted, you could use this x value of 25, plug that in. It would give you the same thing. 25 plus 4 is 29. 25 plus 4 is 29. You'd end up with 145 equals 145. All right, so in that case, the check actually took longer than solving the problem because I checked it incorrectly, but it made me think about it a little bit more, and now I'm more confident in my answer. Here we have 2 times the quantity p plus 1 plus 8 times the quantity p minus 1 equals 5p. What value of p is the solution of the equation above? So what value of p will make both sides be equal? Just basically solve for p. We've got 2 times p plus 1 plus 8 times p minus 1 equals 5p. I'm going to start by distributing. So 2 times p would give me 2p. 2 times plus 1 is plus 2. Here we have 8 being distributed, so that's going to be plus 8p minus 8. Right? 8 times p, 8 times negative 1. And this is all equal to 5p. All right, so I'm going to combine my like terms. 2p plus 8p gives me 10p. And 2 minus 8 give me negative 6. So 10p minus 6 equals 5p, which if you want, you could just say, all right, well, that means this one's 5p more than this one. and it's only, you don't have to subtract it by 6. So 5p would be equal to 6. You could think of it that way. I'm just going to do it the standard way so that, if someone doesn't feel as comfortable with doing those leaps in your head, then you can just show your work. So minus 5p on both sides, that would give you 10p minus 5p is 5p, right? You had 10 p's, take away 5 of those p's, you have 5 p's left. And here I'm adding 6 to both sides to get rid of the negative 6. Right? Minus 6 plus 6 is 0, that cancels out. So we get 5p equals 6. So p would be equal to 6 over 5. I'm just dividing both sides by 5 to get rid of the times 5. P equals 6 fifths, right? Which, like I said, 5p would be equal to 6, right? Because you have to subtract 6 from the 10 p's to make them equal to 5 p's. So if 5p equals 6, then it makes sense that p would be 6 divided by 5. All right, so p equals 6 fifths. This one, there's no answer choices, but if you want to check it, you just plug it back in. So you'd say, all right, 2 times 6 fifths plus 1 plus 8 times 6 fifths minus 1 should be equal to 5 times 6 fifths. Okay, well, in this case, 2 times, or we could just say 6 fifths plus 1. 1 is the same as 5 fifths. So that would be 2 times 6 fifths plus 5 fifths. 1 is equal to something over itself, plus 8 times 6 fifths minus 5 fifths is equal to, well, 5 divided by 5 is 1, so it just leaves you with 6. So this should all be equal to 6 ultimately. 6 fifths plus 5 fifths would give you 11 fifths. So 2 times 11 fifths plus 8, let's see, 6 fifths minus 5 fifths would be 1 fifth. 8 times 1 fifth. 2 times 11 is 22, so we have 22 fifths plus 8 fifths should be equal to 6. 22 plus 8 is 30, so 30 divided by 5 equals 6. Well, that's true. 6 is equal to 6, so that checks out. All right, so 6 fifths would be our answer. If you wanted to write it as a decimal, then would that be 1 and 1/5, so 1.2. Right? That would also be an acceptable answer. If 4x minus 1/2 equals negative 5, what is the value of 8x minus 1? All right, so a lot of times, again, when they ask you, I've said this on a lot of the questions have a similar thing, where they're asking for something that's not x, it's going to be either a part of the answer or a part of the original equation, or something you could do to one of the sides of the equation to make it like that. So just if we look at 4x minus 1/2 and 8x minus 1, you might want to train your brain to recognize this if you don't see it immediately. But this blue one right here, the 8x minus 1, is just double the red one. So 4x minus 1/2. Right? If you multiply this whole thing by 2, it's equal to 8x minus 1. Right? 2 times 4x is 8x, 2 times negative 1/2 is negative 1. So if we want to solve for 8x minus 1, you can do it without finding x by just doubling both sides. So double this side and double this side. So you're multiplying both sides by 2. If you multiply a expression with multiple parts, so in this case it's a binomial, you have to multiply all the parts by 2, right? You're distributing that 2. So in this case, 2 times 4x gives us 8x. 2 times negative 1/2 is minus 1. Right? This is the thing that we want. It's equal to negative 5 times 2, which is negative 10. Now, again, you're very welcome to just solve for x as well. So you could get 4x equals negative 5 plus 1/2. I just added 1/2 to both sides to get the 4x alone. And then you get 4x is equal to, what would that be? This is 10 halves plus 1/2, or negative 10 halves plus 1/2, which is negative 9 halves. And then to get rid of the times 4, you would just divide by 4. So you get that x is equal to negative 9 over 8. And then once you have x equals negative 9 over 8, you could plug that into 8x minus 1. So 8x minus 1 would be equal to 8 times, we said x is negative 9 over 8. So 8 times negative 9/8 minus 1, which would give you, right, the 8's cancel here. So negative 9 minus 1, which is equal to negative 10. Right, so you get the same answer that we got. You could do it by solving for x. Again, just be really careful. They did make negative 9/8 an answer choice here. So if you solve for x, you could incorrectly think that you're already done when you're not. But I would recommend just doing it this way. Just recognize that you can double this to get to this. Sometimes they will just randomly say, what is 3x, when there's no 3x in the equation, just to try to throw you off or to, give you one other step you have to do. But a lot of times when it's something that's a little more complicated, they do have some shortcut, right? Maybe some way that you can get directly from the original equation to what they're looking for. Now, last thing I'm going to say, for any of these, make sure, especially if you have the time, so maybe on your first set when you have a set of easy questions and medium questions and hard ones, maybe start, say, if I have time at the end, I'll come back and check this. Or just if you feel like you're making good time in the first place, just plug it in and check. Here we have, if 2 times the quantity 3t minus 10 plus t equals 40 plus 4t, what is the value of 3t? All right, well, there is a 3t here. That could potentially help us. I'm just going to solve for t, and just make sure you remember at the end that we're looking for 3t, not t, because they don't even have multiple choices that could potentially help you. So start by distributing the 2 here. 2 times 3t is 6t. 2 times negative 10 is negative 20, plus t equals 40 plus 4t. All right, so if we combine our like terms over here, 6t plus t is 7t. So we have 7t minus 20 equals 40 plus 4t. Now we want to get all of our t's together on one side, so I'm going to put them over here. Subtract 4t from both sides, which cancels the t's over here. That gives us 3t. And here, to get the t's alone, we can add 20 to both sides. Minus 20 plus 20 is 0. 40 plus 20 is 60. So 3t equals 60. Oh, what's nice, we're looking for 3t. Well, we already have 3t here. Just by trying to solve for t, we got to 3t. So that'd be 60. I mean, t is 20. Just be careful with this because, you might get excited and just write t is 20 and then move on to the next question. Take that extra 5 seconds to just recheck. What are they looking for? 3t at 60. All right. And if you want to check it, like we know if 3t is 60, that means that t is equal to 20, right? A third of 60. So you can plug that in. 2 times 3t, we said was 60. So 2 times 60 minus 10 plus, we said t is 20, equals 40 plus, I need to move this over so I have a little more space. 40 plus 4 times 20, t is 20. So see if those two are equal. 60 minus 10 is 50. So we get 2 times 50 plus 20 should be equal to 40 plus 4 times 20 is 80. 40 plus 80 is 120 on the side, and 2 times 50 is 100. 100 plus 20 would be 120. So 120 equals 120, that checks out. All right, so that is correct. Here we have, if 6 over 7 times p plus 18 equals 54, what is the value of 7p? Okay, again, they're not asking for p, they want 7p, so just don't let that make you lose points. I'm going to just start by solving for p. So subtract 18 from both sides. I guess I won't erase that, but that gives us 6/7 times p is equal to, right, the 18 minus 18 is 0. 54 minus 18, so minus 8 will bring us down to 46, and then minus 10 would be 36. Right, 36 plus 18, 54, that's correct. All right, now to get the p alone, we can just multiply both sides by 7 over 6. Right, that's the reciprocal of 6/7. So you can think of it as the 7 divided by 7 is 1, the 6 divided by 6 is 1. Leaves us just with p is equal to 36 times 7, 6. Well, 36 divided by 6 is 6, so 6 times 7 is 42. All right, we have p is equal to 42. Again, they want 7p. So just don't forget that. 7 times p would be equal to 7 times this 42. And 7 times 42, let's see, 7 times 4 would be 28. So this is 280 plus 7 times 2 is 14. So 280 plus 14, which would be 294. Right, you can type that in a calculator as well. It should give you the same thing. Remember, on the SAT, they now give you a calculator for the entire thing. So while I'm trying to do a lot of the math on paper in my head, you don't need to. I'm trying to think, is there a way to check this? This one, the 7p is not easy to check. You could check it with the 42, right? You could plug that 42 in. 6/7 times 42 would give you 36. 36 plus 18 is 54. All right, so as long as I multiplied 7 times 42 correctly, then this should be right. Megan's regular wage at her job is P dollars per hour for the first 8 hours of work in a day, plus 1.5 times her regular hourly wage for work in excess of 8 hours that day. So she's getting 1.5 times for overtime. That's good. On a given day, Megan worked for 10 hours, and her total earnings for that day were $137.50. What is Megan's regular hourly wage? Okay. So for 8 hours, she made her hourly wage. We can call that X, or let's call it W for wage. 8 times W. And then for 2 hours, right, the first 8 hours she makes her wage, then any additional hours. So she did 10 hours, that's 2 hours more than the 8 hours. So 2 hours, she made 1.5 times her hourly wage. So 2 times 1.5 times W. And that will all add up to 137.5. All right, so just be careful. I think some people might interpret this as if she worked more than 8 hours, they would think that means she's making 1.5 for those whole 10, especially, if they're not familiar with how overtime works. But in this case, she's making her regular wage for those first 8 hours. And then once she starts working in excess of 8 hours, so anything more than 8 hours, she's making 1.5 times, right? So 8W plus 2 times 1.5W. This is essentially she's getting paid as if she did 3 hours above that 8 hours. Because both of those 2 hours she made time and a half. Right, so 8W plus 3W, we just think 2 times 1.5 is 3, equals 137.5. And usually we just write in the 50 because it's, you're writing all the way to the cents. But 8W plus 3W is 11W. All right, so we have 11 times W equals 137.5. To find, what are we just looking for? The regular hourly wage, just divide both sides by 11 to get W alone, right? Because 11 times W is 137.5. So divide by 11, you get just 1W, or W is equal to 137.5 divided by 11. I'm going to do long division here. This would be a good use of a calculator if you have one. But 13 minus 11 gives us 2. 27, 11 goes into that twice. It's 22. Get 55, so 12.5. So it makes $12.50 an hour. All right, and then you can check that. 12.50 times 8 would be 100. And then for the additional 2 hours, she's making 12.50 times 1.5, which, let's see, half of that would be 625. So she's making 18.75. So 18.75 times 2 would give you 37.50. So yeah, 100 for those 8 hours and then 37.50 for the additional 2 hours. Okay, so that does add up. Now, a bowl contains 20 ounces of water. When the bowl is uncovered, the amount of water in the bowl decreases by 1 ounce every 4 days. If 9 ounces of water remain in this bowl, for how many days has it been uncovered? So the assumption is if it was covered, you lose nothing. Right? A bowl contains 20. So you start with 20. That's your initial value. And then you lose 1 every 4, which you can think of that as you're losing 1/4 every day. Right? So 1/4, how many days? So 1/4 times the number of days. And that leaves you with 9 ounces. Right? So you see we're getting this from 20 is what you started with, your original amount. You're losing 1/4 per day of an ounce. 1/4 per day times the number of days is the total amount you lose to get to 9. All right, so now we're just trying to figure out how many days passed. So I'm going to get my days on this side. Or, I'll just leave it as, I'm going to do the days on this side. So the reason I'm doing this is just so that I don't have to deal with the negative. And you can argue it ends up being more steps. It's not really worth it. But that gives me that 20 is equal to 1/4 times the number of days plus 9. And now to get the days alone, we're going to subtract 9 from both sides, which gives us that 11 is equal to 1/4 times the number of days. So you can think of this as how many days would you have to lose 1/4 of an ounce so that you lose 11, right? We know we lost 11 because it went from 20 down to 9. So now we know 1/4 times d is 11. We want to find just what d is, the number of days. So the opposite of times 1/4, you could think of it as divide by 1/4, but I would just say times 1/4 is like dividing by 4. Opposite of that is, the inverse of that would be multiplying by 4. So we multiply both sides by 4. That gives us that d, the number of days, is equal to 4 times 11 is 44. It's been 44 days of losing a quarter of an ounce. All right. 66x equals 66x. How many solutions does the given equation have? It has infinitely many, right? No matter what x is, x could be 0, x could be 1, x could be -5, x could be 1,000,000, right? It's going to be the same on both sides. 66 times the same number is equal to itself. Okay? So infinitely many. 4x plus 12 equals, on the numerator we have a times the quantity x plus 3 divided by the denominator is 2. In the given equation, a is a constant, so it's just going to be a number. We don't know what the number is yet, but it's not a variable. If the equation has infinitely many solutions, what is the value of a? They really love these infinitely many solution ones, but essentially we want to make sure that it's the same on both sides. We could go, what do you need this to be to make it equal to 4x plus 12? Or what I'm actually going to do is I'm going to try to make the left side look a little bit more like the format of the right side. So we want to have something times x plus 3, right? So 4x plus 12, right? These both have 4 as a factor, so you can pull that 4 out, and it's 4 times x plus 3. Right, so 4 times x plus 3 is equal to a times x plus 3 over 2, which in both of these cases you have an x plus 3 being multiplied by something. Right, so we can basically divide both sides by x plus 3, you can think of it that way. And we get 4 is equal to a over 2. Right? In this case, it's times a divided by 2. That's multiplying by a halves, and this side is multiplying by 4. Right? That's like the coefficient out front for this whole thing, x plus 3. So when is a over 2 equal to 4? Well, that would be when when a is equal to 8. Right? 8 divided by 2 is 4. You could also think of it as divide both sides, or multiply both sides by 2 to get rid of that divide by 2. That gives you that a is equal to 8. Right, so you could do that, and then to check if it actually works, just plug it back in. So 8 times x plus 3 over 2. We'll distribute the 8. That gives you 8x plus 8 times 3 is 24. 8x plus 24 divided by 2. 8x divided by 2 is 4x. 24 divided by 2 is 12. Right, 4x plus 12, which is the same thing on this side. Right, so that would be infinitely many solutions because you have the same on both sides. It's always equal to itself. What are they asking for? What is a equal to? It's 8. Now, I know this is not the only way to do it, but I think this is a good way to do it. I've shown on a similar problem how to do it the other way. And because this one's multiple choice, what's nice is if you didn't feel comfortable with this or you don't feel confident in your answer, maybe you did it, you feel like you might have gotten it wrong, they give you 4 choices. So just plug them all in for a, plug each of them in, and then see which one gives you 4x plus 12. I just showed over here, if you plug in 8 for a on the right side, it does give you 4x plus 12. Right? But even if you didn't know 8 was the answer originally, you could try it for 0, try it for 3, try it for 8, try it for 12. 8 would be the only one that works. Right? Because if you do 0, then you get 0 over 2, which is not equal to 4x plus 12. Right? There'd be one solution for that when x is -3, but you plug in 3 here, that would give you 3x plus 9 over 2. Again, that would be one solution. 12x plus 36 over 2, give you 6x plus 3. That's not what you're looking for. So, or plus 36, no, 6x plus 18. Again, still not what you're looking for. All right. Here we have the width of a rectangular dance floor is w feet. Right, so the width is w feet. The length of the floor is 6 feet. Oh, 6 feet. I'm rushing there. The length of the floor is 6 feet longer than its width. So it's 6 plus w. Right, so we still don't know what the length is. We just know it's 6 longer than w. Which of the following expresses the perimeter in feet of the dance floor in terms of w? The perimeter is just going to be adding up the 4 sides. It's a rectangle. So you think of it as 2 times the length plus 2 times the width, or just draw it out like this, and you'd get, right, w plus w is 2w, And then you have 6 plus w plus 6 plus w. That's 2 times 6 plus w. Right? It still ends up being the same, 2 times the length times 2 times the width. That gives you 2w plus, distribute your 2, plus 12 plus 2w. So 2w plus 2w is 4w plus 12. Right, so 4w plus 12. Just be careful here. They are trying to, they do have this option, which is annoying. This is the area, but they ask for the perimeter. All right, so just take your time. I think the main thing, probably some people will write D for this one, but that is the area. Again, we are looking for the perimeter. 2 times the quantity x minus 5 plus 3 times the quantity x minus 5 equals 10. What is the value of x minus 5? I'm going to do this first the way where you substitute something in for x minus 5. So let's say x minus 5. Let's do d, because I'm done with them asking for these. So you'd say it's 2 times d plus 3 times d is equal to 10. So we have 2 d's and then 3 d's. That's 5 total d's equals 10. What times 5 makes 10? D has to be 2. Okay, so you can think of it that way, which means that x minus 5 equals 2. Right. And then to check that, just plug it in. 2 times 2 plus 3 times 2. Right, I'm plugging in x minus 5, right? So x minus 5 is 2. Plug it in there, plug it in there. It should be equal to 10. 2 times 2 is 4, plus 3 times 2 is 6, equals 10. 10 is equal to 10. All right, so that checks out. That's a shorter way to do it. I will show if you did want to just solve for x. Again, just be careful. If you're going to solve for x, make sure you know they're asking for x minus 5. So do not give x as your answer. They have x here. X should be if x minus 5 is 2, then we know x is 7. So trying to trick you there. Just take your time. Don't rush. Once you've done all the hard math, once you've actually done the algebra, don't forget to subtract 5 from whatever you get for x. All right, so you can distribute this 2. I'll rewrite the whole thing. 2 times x minus 5 plus 3 times x minus 5 equals 10. If you distribute the 2, gives you 2 times x is 2x, 2 times negative 5 is negative 10, plus 3 times x and 3 times negative 5, that's going to be 3x minus 15 equals 10. If you combine your like terms, you get 2x and 3x gives you 5x. Negative 10, negative 15 is negative 25, which is equal to 10. So just add 25 to both sides to get your x's alone. We get 5x is equal to, right, these 25's cancel, or negative 25 and the positive 25 cancel. 5x is equal to 35, which means x equals 7. Again, as I said, don't bubble 7. They did put 7 here because they're trying to be really mean. They might do this on the real test. They want x minus 5. So plug in this 7 for the x. 7 minus 5, which is going to be 2. Okay. You could think of it. X minus 5 is equal to 7 minus 5, which equals 2. All right. I would really recommend, especially if you feel comfortable doing it, plugging in something for the thing that you're solving for. Because then once you solve for D, you'll be like, oh, I solved it. I have my answer. Or it might just stick out to you. It's like, why did I have this other weird variable here? Maybe use like some other symbol or something so that it sticks out to you that it is an odd question. And just plug it in. It actually kind of made this easier. I think it was only a couple of steps if you substitute something in. If you don't, it's really not that bad anyway, but just a lot of people will probably bubble 7 mistakenly. Here we have 1/4 times the quantity x plus 5 minus 1/3 times the quantity x plus 5 equals negative 7. What is the value of x, or what value of x is the solution to the given equation? So this one's similar. They still are doing x plus 5s, but in this case, they actually want you to find x. And we have fractional coefficients. So this is a similar one that we did a couple ago. I think I did this 3 ways before, so I'll do them quickly. We could do the same thing where we substitute something in for x plus 5. We're not solving for x plus 5, so in this case, make sure that you'll remember to go back to it. So let's do, you might want to do something like that will stand out. So I'm trying to think what would be a good example. Like you do a smiley face, right? So you'd say smiley face equals x plus 5. right? Because when you have a smiley face in your answer, you're going to go, okay, there's something's afoot here. And then you'll remember, oh, I solved for x plus 5. I need to find x. All right, so we could do 1/4 times smiley face minus 1/3 times smiley face equals -7. All right, now from here, there's two ways you could do it. You could, find a common denominator so you can combine these two. But you could do that by multiplying the first one by 3/3, multiply the second one by 4/4, and that would give you 3/12 smiley face minus 4/12 smiley face equals -7, which would mean -1/12 of a smiley face equals -7, which some people say that's infinity times smiley face, but don't get confused with that. -1/12 times smiley face equals -7, so you can multiply both sides by -12. I'm multiplying by the 12 to get rid of the 12 in the denominator, multiplying by negative to get rid of the negative. So multiply both sides by -12. Negative times a negative makes a positive, and 7 times 12 would be 84. So that means smiley face equals 84. And now, again, it's like, why do I have a smiley face there? Oh yeah, because smiley face is x plus 5. So x plus 5 equals 84, which means x will be 5 less than that. So you just subtract 5 from both sides. We get that x is equal to 79. Right? And then to check that, you could just plug the 79 back in and solve for it. All right, so this is one way you could do it. The other way, I think I started saying it and then I didn't say what the other thing was. You could get common denominators, or you could multiply by what would end up being your common denominator, 12. So multiply by 4 and multiply by 3 for every term, and then you get rid of the fractions. You don't even have to deal with them. That's one way that you could do it without even doing the substitution way. So this one, technically mixing and matching those different options of, do you do the substitution thing, the smiley face, and do you get rid of the fractions, or do you just deal with them by doing common denominators? There's 4 different ways you can do it just there, and I'm sure there's other solutions as well. But now I'll just show you quickly how you could do it if you don't want to have to deal with the fractions. So 1/4 times x plus 5. In this case, I won't use the smiley faces. I'll just do it the standard way. That takes a little longer. In this case, it doesn't take that much longer though. Equals -7. All right, so we want to get rid of a 1/4 and we want to get rid of a 1/3. So we're multiplying everything by 4 and multiplying everything by 3, which you can think of as multiplying by 12. Right, 4 times 3 is 12. So 12 times this, 12 times this, 12 times this. Just make sure that you multiply all of the terms. In order to multiply, and you shouldn't multiply the x and the plus 5 by 12, like separately, because when you multiply the coefficient up front by 12, that will be distributed to both of them. Right? Both of them will be ultimately multiplied by that 12. Right? So it's just this term, and the -7. So 12 times 1/4 gives us 3. So it's 3 times x plus 5. -1/3 times 12, right? 12 divided by 3 is 4, so it's going to be -4. -4 times x plus 5 equals -7 times 12 would give you -84. All right, so now we distribute. So 3 times x, 3 times plus 5, that's going to give you 3x plus 15. And then here we're distributing -4. Make sure you distribute the negative, so don't forget that. -4 times x is -4x. And again, the negative is getting distributed to this plus 5 as well. It's because we're subtracting this whole thing. So -4x minus 4 times 5 is 20. Equals 84, or equals a -84. Don't forget the negative sign. Now we combine our like terms, so 3x and -4x. If you have 3 of something and then you lose 4 of something, then you have -1 of them. So that's -x. Let me do that maybe in pink so it doesn't get as confusing. So -x, and then we'll do the constants 15 and -20. 15 minus 20 is -5. So -x minus 5 equals -84. Now we want to get the x alone, so I'm going to add 5 to both sides, which gives me that -x is equal to -84 plus 5. If you add to a negative number, you're making it less negative. So the absolute value actually goes down. Be -x equals -79. And if negative x equals negative 79, that means x equals positive 79. You can think of that as multiplying both sides by a negative, dividing both sides by a negative. It's the same thing, negative 1. Or you could just think, right, negative blank equals negative blank, then blank equals blank, right? So like the thing after the negative is the same. Right, so x equals 79, right, which is the same answer that we got here. Again, to check that, just plug it back in, especially if you have a calculator, do 1/4 times parentheses, 79 plus 5, end parentheses, minus 1/3 times parentheses, 79 plus 5, end parentheses. It should give you negative 7. Here we have 9 times the quantity 4 minus 3x and quantity plus 2 equals 8 times the quantity 4 minus 3x and quantity plus 18. What is the value of 4 minus 3x? All right. So I know I've shown these a bunch of times and I've been doing it both ways. I'm just going to do it the one way here because I think this is the better method. If you just skipped to this question and you checked it and you did a different way, you solved for x, that's okay. You can solve for x, or you can use guess and check by plugging in these 4 options for x, see which one works, where both sides are equal. Both of those options are fine. But I'm just going to say, we'll do 4 minus 3x equals c. I'm just looking at my chair. So c is equal to 4 minus 3x. You can think of it as this is like a little cheat code, right? We're just skipping around. I think this is what they want you to do. That's why they give you the 4 minus 3x, but you could do it many ways. So we have 9 times c, right? Because c is here, 4 minus 3x, plus 2 equals 8 times c, right? 8 times 4 minus 3x, plus 18. And now we're just solving for c, right? We're solving for 4 minus 3x. And again, if you do it the way where you just solve for x, just make sure that you plug it into this 4 minus 3 times your answer there. But 9c, we're going to get our c's together on one side, so I'm going to subtract 8c from both sides. 9c minus 8c gives us just 1c, which is c. And then to get them alone, we're going to get rid of this plus 2 by doing minus 2 on both sides. So c is equal to 16. Again, we said c is 4 minus 3x, so 4 minus 3x is equal to 16. Right, that's our answer. To check that, you could plug the 16 in here and here. So 9 times 16, because this whole thing is 4 minus 3x. So 9 times 16 plus 2 should be equal to 8 times 16 plus 18. Which actually makes sense because, right, basically you've got 8 16s here plus another 16 plus 2. Here we've got 8 16s plus another 16 plus 2. Right? So 9 times 16, that would be, let's see, 160 minus 16 would be 144 plus 2 equals, and this would be 128 plus 18. So 144 plus 2 gives us 146 equals 128 plus 18 is also 146. Right, so that checks out. A candle is made of 17 ounces of wax. When the candle is burning, the amount of wax in the candle decreases by 1 ounce every 4 hours. Okay, it's the same thing as the other one was loses 1 ounce every 4 days. If 6 ounces of wax remain in the candle, for how many hours has it been burning? So if you want to write this as an equation, you could say, all right, if it loses 1 ounce every 4 hours, that means every hour it loses 1/4. Right? And it's still in hours. If they did something with minutes, and you just do like, a fourth of an hour is 15 minutes. But we're not doing minutes, so it would be you're losing 1/4 for every hour. Let's say each is the number of hours. You started with 17, so you could do plus 17 there if you want to write it more like a linear function, but I'll just put the 17 up front. 17 minus 1/4 h, and you end up with 6. All right, so you could do it that way. Now, you could also go, okay, we went from 17 down to 6, so it lost 11. Right? 11 is the change, so negative 11 is equal to the amount you're losing, so minus 1/4 times h. Or you could just go, right, multiply both of these by -1, or you go, all right, we lost 11, so 11 is how much burned, and the amount that's burning per hour is, or the one, what do they say, decreasing, the amount it's decreasing per hour is 1/4 times h, so you can think of it that way, right? So how many hours have to pass for you to lose 11 ounces? Well, to get rid of the times 1/4, you multiply both sides by 4, the reciprocal of 1/4. 4 divided by 4 is 1, so we just get 1h is equal to 4 times 11 is 44. So take 44 hours. Right? And if you plug 44 into this original function, that would work. You could also use this original function, right? That's the same thing. 17 minus 6 is 11. Then you plus 1/4 on both sides, 1/4 eighth each. All right, and that's the last question. All right, so maybe I'll just show quickly that does, since it's the last one, that does give you the correct answer. So if we plug in our value of h, which was 44 for this original equation that I wrote, we'd get 17 minus 1/4 of 44 is 11. So 17 minus 11 should be equal to 6. 17 minus 11 is 6. So 6 equals 6. That checks out. Okay, so that's how you would do that. That is every medium algebra question in the specific skill linear equations with one variable. Now they have a bunch of other skills that still fall into algebra. There are actually some of the questions, if you're going through the question bank, for some reason algebra, it's mostly just focused on linear functions and linear equations and linear relationships. There are two other sections that, there's one that's algebra, one that's geometry, and then there's one that's called advanced math. And advanced math has a lot of things that you would learn in an algebra class. So they just do like non-linear relationships and whatnot like that. They just have some things that would not fall into algebra as well. And then the other one is more of a data-focused thing. So it's data analytics and interpreting graphs and stuff. You might have learned that in an algebra class, but they have that as a separate section. But I will upload videos, hopefully, for all of those topics, going through all of the problems. Remember that all of these have timestamps with the specific IDs. Now you can see in this set, they do have kind of patterns of things they like to ask. So they like to ask for things that aren't x, so some other form, 4 minus 3x or something. And a lot of times you can use it as a shortcut to not actually have to find x, right? To just substitute that in the equation, or manipulate the equation in some way where you don't have to do as much work because you're looking for some other thing. Sometimes they'll give you something that it's not really a part of the equation. So I think there was one near the beginning where they asked for like x minus 7, and there was no actually x minus 7 in there. They have a lot of stuff with those one variable equations that have infinite solutions and that have 0 solutions. So, or just, I think there was one question, I don't know if it might have been an easy set where they said, how many solutions would this have? And it was 1 solution. And it was kind of a trick question. It was just like a normal linear equation that you could solve for the variable. So make sure you're comfortable with those. Practice the word problems. They don't have too many in here. I think there will be more probably word problems in the hard section, and then maybe in the linear functions section. But yeah, make sure you're comfortable writing something like this. This one, it's an important skill or an important thing to understand, even if you're not doing a job that pays overtime, to understand how overtime pay works. So I think if you're familiar with that, then this question is a little easier to set up. Either way, you could interpret it just from the thing that they wrote there. And yeah, make sure you're comfortable distributing using the distributive property, even if you're distributing a negative coefficient. Make sure that you're comfortable with dealing with fractions in an equation. You could either do it by eliminating the fractions, multiplying by the least common denominator in a way that will get rid of all of those fractions, or just getting fractions with different denominators, even if they're coefficients, to be the same denominator, so you can add or subtract those. And yeah, I'm trying to think if there's any other main topics that came up here. I think that kind of covers your bases. Do definitely make sure that you're comfortable just with standard algebra. That mostly comes from practice. So, right, solving an equation, even if it has a lot of different parts to it. But yeah, I do think that is pretty much all you need to know for this. Make sure you know the difference between a constant and a variable. They're not going to have like a vocab question on that, but it could help you understand what some of the questions are asking for. And yeah, the hard video should be coming up soon. But if you have any questions, feel free to comment them below. I did try to do a pretty comprehensive walkthrough of these, so showing how to do them, all of the different ways that you could do them, and how you can check your answer. But I'm sure there are some other solutions that you could do. Maybe if you know some shortcuts that you could use on a calculator or use a calculator to do, I would recommend putting those below. If you caught any errors that I made, Feel free to comment those below. And yeah, thank you for watching, and let me know if you have any specific questions.